Okay, ladies, welcome to the last video of your 2018 school year. So, 11.6 is circle proofs, and so is 11.7. So, we're just going to talk about some theorems you need to know, and then it's mostly about just practicing them. So, recall this information. This is from both Unit 10 and 11 because both of these units are circle units. So, an angle inscribed in a semicircle is always a right angle. So remember, if it's inscribed in a semicircle, we take half of 180, and that's how come we get a right angle. Inscribed angles that intercept the same arc are congruent. So if we have that arc, we take half that arc to get the angle, and that's why both of those angles are congruent. The measure of an inscribed angle in a circle is 1/2 the measure of the central angle. So remember that if we had a central angle here and it opened up to the arc, this angle and the arc would be equal, and then we would take half that arc to figure out the angle. The opposite angles of a cyclic quadrilateral, that just means it's inscribed in a circle, are supplementary. So angles across from each other, that's from Unit 10. Remember that a tangent and a radius form a right angle. Parallel lines intercept congruent arcs on a circle. That's from 10.6. If two chords in a circle are congruent, then their intercepted arcs are congruent. So if those two chords are congruent, their arcs are congruent too. That's from 10.6. The perpendicular bisector of a chord is a diameter. So remember, if a diameter cuts a chord perpendicular, it bisects it as well. So that's also from 10.6. Two congruent chords in a circle are equidistant from the center of the circle. So if the chords have the same distance from the center out, that means they're the same length. Again, that's from 10.6. And then lastly, tangent segments to a circle from an outside point. The two tangents are congruent. And that was your party hat theorem. And just a reminder that all radii are congruent. So we're going to use some of these, and then we're also going to use like our proof skills from Unit 4. So that was our proof unit. So if you have your proof toolbox, I would take that out as well, and then you could add these to that last page, and then you could have a whole proof toolbox complete. So I'm going to do one problem with you, and then the rest you're going to try on your own. I'll show you the next one so you can check your answers as you go on. But let's start with this one. So it says, given diameters A, B, and CD, prove that arc AC is congruent to BD. So like always, we need to set up our statements and our reasons columns, since this is a proof. So, statements and reasons. Statement 1 and reason 1 are always the simplest. Remember, for statement 1, we write our givens, and then our reason is given. So statement 1 is diameters AB and CD, and our reason is given. So now, looking at this, I know I have two diameters here, AB and DC. Well, remember that diameters are just really two radii. So, and all radii are congruent. So I can say that AO, BO, DO, and CO are congruent because all radii are congruent. So let's write that. AO is congruent to CO, is congruent to DO, is congruent to BO. And we can say all radii are congruent. Now, you might notice this as well, because this is something that we always notice. Angle 1 and 2 here are indeed vertical angles, so we can write that next. So angle 1 is congruent to angle 2. And we can say vertical angles are congruent. Okay, so if I have three things marked in my triangle, remember I can say the triangles are congruent. So I can say triangle AOC is congruent to triangle BOD by saying side angle side. Okay, so what we did is we just proved these triangles congruent. However, I need to prove that these arcs are congruent. And remember, one of the theorems was that congruent arcs have congruent chords. So I need to prove somehow DB is congruent to AC. Well, if I know the two triangles are congruent, then I can say that because of the two triangles are congruent, everything else about them is congruent. Remember, that's called CPCTC. So we can say that AC is congruent to BD because of CPCTC. And now, if we know the chords are congruent, then the arcs must be congruent. And we could either say we could write that out, or you can use congruent chords and arcs theorem. So I'm going to say two congruent chords have the same intercepted arc measure. So again, you just have to take these nice and slow. There was another way you could have done this. You could have showed that they're vertical angles, and then you could have used the central angle theorem, where DOB is a central angle. So since both of those angles are vertical and they're central, the arcs have to be congruent. So you didn't have to prove the triangles are congruent, but that was just one way. So there's many ways to do this. I want you to pause the video. I want you to go on to the next one, and then I'm going to show you the answer. You're going to try the rest of these and then submit it, and then 11.7, it's just going to be practice. So there's two sheets on that before 11.7 that have answer keys to the proofs that you can try, and then 11.7 is just a blank sheet that you can submit. So here is the answer to the next problem. You could have done it a different way, remember? But other than that, it's just about practice and then Unit 11 test.